Today I'm just going to run through a bunch more examples of doing basic derivatives, and we're working on something called the power rule right now. Okay, so we're working with the exponents. We're also going to be doing a little bit of trig derivatives, and remember the little signs that indicate we're doing derivatives. We have d dx, f prime of x, dy dx, and y prime. So anytime we see any of these, they're asking us to do the derivative. All right, and remember the derivative helps find the slope at any given point of a function. So getting right into it. Now a lot of the rules we wrote down, or at least I wrote down in the previous video, so if you need to refer back to that one or have it written down somewhere, that would be pretty helpful. But I'll also throw them into today's video. So let's say they give us y equals x to the 9 plus 10x squared minus 9, and they want us to find the derivative, so we want to find y prime. Okay, so we use the same notation that they use in the original problem. All right, remember, we take this piece by piece. So one piece, two piece, three piece. So on the first one, that is a variable x with the exponent 9. So that exponent has moved to the front, so 9x, and then the exponent kind of moves down 1, so 9 minus 1, 8. So same thing for the next one. Exponent moves ahead of this, so that's a 2 times the 10x, and then exponent moves down by 1, so it's just an x to the 1. Minus, now 9 is just a constant number, and anytime you take the derivative of a constant, it just becomes 0. So technically that is a correct answer if we clean it up. We've got 9x to the 8. Next one becomes 20x. And then minus 0 doesn't really need to show up. So there we go. All right. Now, pretty simple one here. We're just trying to find the derivative of it. It's just a constant all by itself. So the derivative of a constant is 0. Negative 4x to the 4 plus 3x cubed plus 10. So another three-piece problem. So the derivative of this is, okay, we move that down, that one moves down. Now we can kind of do this in our heads now. Negative 4 times that 4 gives me a negative 16. X to the 1 lower, 3. Plus 3 times 3 is 9. X, and then 1 lower, squared. 10 is a constant or a number all by itself, so when we take the derivative of that, it becomes 0, so we don't need to show it. Alright, so hopefully you're finding the patterns to these. These are polynomials using the power rule. We can use the same things when the numbers get bigger. Y equals negative 13, x to the 18, minus 17x to the 12. So now it's just two pieces. The numbers are a lot bigger. So finding the derivative, so y prime is, so we've got to do 18 times this negative 13. So negative 13 times 18 is negative 234. X to the 1 lower, 17. Minus 17 times 12, that gives me a 204. X to the 1 lower, 11. So once you start getting the hang of these things move a lot faster. Okay, no matter what the numbers are, it's really just a bunch of multiplication and then just knock the exponents down by 1. Alright, so let's find the derivative. So y prime, 10 times 17 is 170. X, 1 lower to the 16, plus 7 times 6 is a 42. X to the 1 lower, 6, plus 4 times 3, 12. X to the 1 lower, 2. Alright, so these are a bunch of polynomial ones. I'll jump into some trig functions now. So let's say they gave us f of theta equals 3 cosecant theta plus cotangent theta. Alright, so again, built of two pieces. This one here, this one there. Now the 3 in the front, alright, that's a coefficient. Okay, it's already being attached up there, so we don't really need to do too much with a 3. Remember, the stuff in the front doesn't change too much. We do want to indicate that we're finding the derivative. So this is going to be f prime of theta is what my answer is going to be. Now, if we look back for trig functions, right here, cosecant theta, when we take the derivative of cosecant, I'll write it down here, cosecant, the derivative is going to be negative cosecant theta times cotangent theta. Alright, for cotangent, when we take the derivative of it, so that's saying take the derivative of it, derivative of cotangent is going to be negative cosecant squared theta. So that's what I'm going to replace both of those with. Alright, so cosecant theta becomes negative cosecant theta cotangent theta, but in front of that still the 3, plus cotangent is going to become negative cosecant squared theta. You see how I just replaced this with this and that with that? And we can clean it up in one more step. So that's going to be a negative 3 cosecant theta cotangent theta minus cosecant squared theta. Alright, so there is the derivative. Alright, so these were the rules from yesterday's video. So if you want to take a look at those to refer back to, you go ahead. Let's try another one. Let's say they gave us f of theta equals 3 tangent theta minus 2 secant theta. So I want to find the derivative. Okay? Tangent. So if I look back to yesterday's, or the rules, the derivative of tangent theta is secant squared theta. Alright, so that's going to be 3 secant squared theta, that becomes that, minus 2, now we got to do secant. Alright, so the derivative of secant is secant theta times tangent theta. So that's going to get replaced over here. And actually we don't need the parentheses, that's just going to come out nicely. We just need to multiply it to the 2. So we've got secant theta, tangent theta, and there's really nothing else to clean up there. So there's our answer. Alright, and just a couple more here. We have the little combos of not polynomials, but these regular terms and trig functions together. Let's say it said h of x equals 9 cosine x minus 7 x squared. They want us to find h prime of x, the derivative. Now the second part we already know how to do. That comes down and becomes negative 14, 7 times 2, 14, x to 1 lower, so just a 1, where it doesn't need to show up. Here we do it like before. Cosine is going to become something. Remember, make the little note down here. The derivative of cosine x is going to come out to negative sine x. So the 9 is going to get left there. I can move the negative sign to the front, and then I'm going to write the sine x right there. Alright, there we go, derivative. So you're just taking it piece by piece, seeing what the whole thing comes out to. One last example here. let's say f of x equals 2x minus 3 sine of x. Again, two pieces. We have the 2x and then the 3 sine x. So we want to find the derivative, so f prime of x. Now, if it's 2 or just a number and an x together, this exponent's 1. Alright, so when you move that 1, it doesn't really change the 2. But remember that exponent drops down, so it's x to the 0, or else it just disappears. So if it's 2 or a number with just the x, just the number is going to survive. So it's just going to be a 2. Because x to the 0 is 1, and that kind of just disappears. Minus, and then the note down here from the rules from yesterday, the derivative of sine x is cosine x. So we're going to replace this with cosine x, so negative 3 cosine x. Alright, so just a little bit more review on these derivative type problems.